Hello everyone, welcome back to the course Introduction to Infrastructure Asset Management. We started our discussion around generic infrastructure asset management process. We saw data collection, different aspects of data collection. In the last lecture, we talked about performance modeling. We discussed what is infrastructure performance and how do we go about modeling it. Now, I will discuss the third aspect in this particular diagram, which is development of alternatives. In case of infrastructure asset management, development of alternatives is nothing but the selection of maintenance activity, what type of maintenance we want to do. So, this particular lecture, the second lecture in the week, is focused on understanding the role of maintenance and maintenance alternatives. This is part of the decision framework which we started in third week. So, let us start with understanding what is the role of maintenance. To understand role of maintenance, we can actually talk about what happens if we do not do maintenance properly. So, say there is a poor infrastructure asset management practice. What will happen in this case? Any infrastructure which is subject to poor infrastructure asset management practices will eventually lead to reduced service life. So, if an infrastructure is designed for say 100 years, if you do not do maintenance at the right time, then you will often see that there is reduced service life. Moreover, the cost of replacing damaged parts will be higher. If we do not do maintenance at the right time, the cost of replacement will be much higher. Next, we have the issues of health hazards, safety issues, as well as user unrest. So, if there is an infrastructure asset which is not maintained properly, there is a high likelihood that there are some potential hazards and safety issues associated with it. Next up, there are issues of reduced quality and reduced user experience. Any infrastructure asset, if not maintained properly, will lead to these aspects. It will reduce the service life, it will reduce the quality of the user who is using it. If at all we plan to do maintenance at a later stage, those maintenance activities will be very expensive. So, it is important that we do maintenance at the right time. Let us discuss the role of maintenance in detail. Role of maintenance is very important and critical, especially because it runs concurrently with the utilization phase. That is, once the construction of a project is complete, we move towards utilization stage. This is where we are utilizing the asset, and any maintenance activity has to be done in parallel, and this is the longest phase of an asset's life. For any given project, planning and construction phase is typically 4 to 5 years. However, the utilization phase is much longer. For example, for roads, we utilize them for almost 20 to 25 years. For a building, we utilize it for 60 to 80 years, and so on. So, the maintenance phase, which runs concurrently with the utilization phase, is very critical, especially because this is the time when the users are occupying the asset or they are using the asset. So, maintenance becomes critical for ensuring that the infrastructure meets functionality requirements. Also, it meets safety requirements. And finally, it should meet longevity requirements. So, maintenance is important for all these aspects. Next up, maintenance ensures that the infrastructure is operational, it is safe and cost effective throughout its life cycle. I will talk about these in the subsequent slides. Focus of maintenance is basically on extending the life of an asset. Here, the idea is if maintenance is done at the right time, then the overall cost of maintaining an infrastructure asset will be lower. So, we try to do maintenance so that the overall cost can be reduced while preserving functionality and quality. Maintenance of an infrastructure asset is critical. Let us see some real world examples. First one, I have an example here of a rail network in France. Back in 1970s and thereon, they focused on development of high speed trains. which resulted in reduction in focus on maintenance, and the spending for maintenance of existing tracks was reduced because the focus was on completely constructing new high speed rails. The overall impact of this was that the network share of the rail where there was reduced speed was almost doubled. There was doubling in the network share where trains can move at low speed. So, this is a very good example where we can see that maintenance, if not done at the right time, reduces the quality of the user's experience. Also, the functionality is reduced. In this case, since the trains had to move slowly, there were increased delays and also suboptimal traffic flow. So, maintenance is important. We should not lose sight of doing maintenance. Another example here is, if you go over exploring blackouts in different parts of the world, there are several electricity blackouts throughout the world. Most of these blackouts are actually because of poor maintenance of transmission lines and electrical lines. Again, this is another example which communicates that doing maintenance is important. If we do not do maintenance at the right time, it leads to failure, sometimes it leads to suboptimal performance. Having discussed the role of maintenance, let us talk about what is the effect of maintenance. Obviously, effect of maintenance is directly linked to the role of maintenance. Any maintenance activity done properly will result in the asset being operational, that is functional, it being safe for use. Also, maintenance will help in providing higher service quality, that is better user experience, and finally, it will be more cost effective throughout the life cycle. So, it will help in longevity of the asset. Maintenance also reduces risks. Safety risks, risk of hazards, etc. are reduced if we do proper maintenance at the right time. Next up, maintenance supports the idea of sustainability and resilience. We will talk about these terms in detail in some of the subsequent lectures. Here, the idea is doing maintenance at the right time helps in sustainability. It includes the 3 E's of economics, environment and equity. At the same time, doing maintenance at the right time improves resilience. Resilience is directly linked to how an infrastructure withstands and copes up during disasters. We will talk about this in detail. For example, in developing countries where there is poor maintenance of water pipelines, we see that there is huge water loss. This water loss is nearly equal to needs of 200 million people. So, what I am trying to communicate here is maintenance is critical for sustainability. From environment's point of view, you want to preserve resources. In order to preserve resources, asset maintenance becomes critical. In this example, we see that in developing world, there are several water pipelines networks which are not maintained. This leads to water loss. This loss is almost equal to the amount of water which gets wasted, which could have actually fulfilled the needs of 200 million people. Having discussed the role and importance of maintenance, let us see how maintenance impacts performance. In the last lecture, we discussed about performance modeling. We saw that a performance curve looks something like this. On the x axis, we had age of the infrastructure, and on the y axis, we had performance. Here, I have shown a curve where say there is no maintenance. If we do not do any maintenance, the performance of an asset is most likely to go down. Here we see that after age of 32 or 33 years, the performance actually goes below the critical performance level. In this case, there is no maintenance considered. Now, the question is, what will happen if we do maintenance on this particular asset? Please think about it before continuing with the lecture. I hope you have thought about it. What will be the impact of doing maintenance on the performance curve? There are two aspects to it. Let us see one by one. Say this particular asset at age nearly 20, we decide to do maintenance. Now, there are two possibilities. The first one is, if we do maintenance at this stage, the performance might go higher. That is, I have done a maintenance here and the performance of my asset increases, and then it again starts to go down. Say again, I do maintenance here and the performance goes higher, and again it starts to go down. This is option 1. The second possibility is, when I do maintenance, the performance stays as is, it does not increase, but the rate of deterioration after this actually decreases. This is another possibility. So, what we have seen is that when I do maintenance, either my performance can increase or the rate of deterioration here can change if I do maintenance. I hope this idea is clear, that doing a maintenance can increase the performance. Sometimes there can be some assets where performance cannot be increased, but we can actually prevent the rate of deterioration, we can lower it down. So, in this case, if I do maintenance, the deterioration goes like this. I might decide to do another maintenance here, and then the curve goes something like this. In reality, what we are trying to do is, we are trying to extend the life of this asset. We do not want the performance to go below this critical level. We understand that as long as the performance is above 60, the asset is serviceable. So, we try to do different maintenance techniques to either increase the performance or to reduce the rate of deterioration from that point onwards. I hope the concept is clear. Having discussed the role of maintenance and its impact on the performance, let us talk about what are the different types of maintenance techniques. The types of maintenance techniques will be dependent on the type of infrastructure you have. In this particular section, we are just discussing a generic framework. So, I will talk about what are the different classifications of maintenance. I will not talk about specific maintenance activities which can be carried out. The types of maintenance includes two main categories. First is reactive maintenance. This is corrective maintenance. On the other side, we can have preventive maintenance. Let us discuss about reactive and preventive maintenance in more detail. Reactive maintenance or corrective maintenance is the maintenance which is done after the asset has failed. Obviously, since we are waiting for the asset to fail, there is no maintenance planning as such. You are just doing maintenance when there is a failure. However, assembling resources after the failure is cumbersome. So, oftentimes it becomes very cost intensive, and it also comes with added unplanned downtime, because you cannot have all the resources ready every time. So, any reactive maintenance leads to higher costs as well as increase in downtime. On the other side, any preventive maintenance is basically a more regular, scheduled, proactive maintenance. Here, we put more efforts into creating a maintenance plan. We have scheduled maintenance. Since we are doing preventive maintenance, it actually comes at lower costs. Also, the unplanned downtime is reduced. So, with preventive maintenance, we save both time as well as money. Within preventive maintenance, we can actually have two different types of maintenance. First is scheduled maintenance, second is predictive maintenance. In case of scheduled maintenance, we have a fixed schedule. We decide that a particular asset will be maintained at a given time, and this will be the appropriate maintenance strategy which will be used. In case of predictive maintenance, we actually rely on the data set. We see and observe the asset, we record the relevant data, and based on the condition of the asset, we decide what type of maintenance should be done. So, I hope the idea is clear. Scheduled maintenance is more of a schedule where you already define at what time what maintenance should be done. In case of predictive maintenance, you assess the condition, you try to understand what is the asset's behavior, and then try to decide an appropriate maintenance strategy. We will discuss this in the later part of this lecture as well. Now, within scheduled maintenance, we can actually have two types of maintenance. One is day-to-day maintenance. So, there can be a list of day-to-day maintenance which needs to be done. For example, if you have any building, you might need to do daily cleaning. If you have a machinery, you might want to oil it on a daily basis. If there are roads, you might want to clean them daily. If you are living in a region where there is excessive snow, you might have to clean the snow daily. So, all these are part of day-to-day maintenance. On the other hand, routine maintenance is more time bound. That is, you say that after every 6 months, I will go and maintain these roads. You might say that after every 6 months, I will paint all the zebra crossings, I will paint the lanes, etc. So, these are routine maintenances which have a schedule with them. So, classifying maintenance techniques based on reactive or preventive is one way of classification. Another way to classify this could be based on the extent of maintenance. Let us talk about that. Any infrastructure asset which has to be maintained, the decision maker has multiple options. The first option is do nothing. They can decide I will not do any maintenance. This itself is an alternative. If you see that the asset has very high quality and it is performing really well, it is not deteriorating at all, then you might say I will not do anything. But in practicality, it is very difficult. So, you decide to do daily or routine maintenance. So, in order to maintain the asset, you want to do daily or routine maintenance. Next up, you might want to do preventive maintenance. This is usually done to extend the life of an asset. For example, in case of roads, you would have seen that they often do seal coats on them. Seal coats are done to extend the life of an asset. It does not do any structural rehabilitation. It just improves the surface quality and it prevents deterioration. Preventive maintenance is done to reduce the damage to the asset. Next up, another option is I might decide to do light or medium rehabilitation. This is more of repair, where you are trying to do a medium rehabilitation or a light rehabilitation. In some cases, the asset might have deteriorated a lot and you have no other option but to do a heavy rehabilitation, or the worst scenario where you might have to do reconstruction. So, all these are maintenance alternatives based on the extent. As you can see, doing nothing is the cheapest, you do not need any money. Daily or routine maintenance comes with some cost. Preventive maintenance comes with some additional costs. Any light or medium rehabilitation will come at higher costs when compared to preventive maintenance. And finally, heavy rehabilitation or reconstruction is costliest. I hope this is clear that when we are maintaining an asset, we have all the options. Each option has a cost associated with it. Now, our goal is we want to optimize the cost. We want to reduce the overall maintenance cost. The decision of choosing one maintenance alternative over another is a function of lot of factors. It includes what is the existing condition of the infrastructure. It also includes what is the rate of deterioration, what is the quality of service, and so on. A decision maker who is responsible for maintenance of an infrastructure asset has several alternatives. At the same time, the life of an infrastructure asset is huge. So, it becomes tricky. The decision maker has to decide what type of maintenance should I do and when should I do it. And that is where maintenance scheduling becomes important. Let us discuss what is maintenance scheduling. Scheduling of maintenance basically means you try to identify what maintenance activity should be done and at what time. It looks something like this. Say there is a decision maker who has 5 assets under him or her. Now, they need to maintain and preserve all these assets. Obviously, the decision maker cannot decide to do maintenance for all the assets at the same time. They will have budget constraints. Moreover, he or she cannot do maintenance every year. They need to maintain all these assets for n years of life. For the time being, let us say 30 years. Now, in case of maintenance scheduling, the decision maker decides that for asset 1 in year 1, I will do a particular type of maintenance, say M1. He can say that once I do M1, I will not do anything in year 2, so do nothing. Year 3, again I will do nothing. Year 4, he can say I will do nothing. Then year 5, he might say I will do M1 again. Alternatively, they could say instead of doing M1, I will actually do M2. That is a different type of maintenance. Then I will do nothing for 2 years, and again I will need to do a maintenance M1 at this particular year. So, this is a maintenance schedule for this particular asset, where he tries to determine that in the first year I will do a maintenance, then next 3 years I will not do any maintenance, then in the 5th year I will do a maintenance, but it will be different from maintenance 1, and so on. Now, for asset 2, say it is a new asset, say it is a road asset. Here the decision maker could say, since the asset is new, in the first year I do not have to do any maintenance, but I understand that it is important to preserve my asset. So, instead of doing nothing, I will do day-to-day maintenance and keep the asset in good condition. So, they might say that for the first 5 years, we will just do day-to-day maintenance. Now, in the 6th year, they might say I will do preventive maintenance, because it is important to do maintenance at the right time. Then they again say I will just do day-to-day maintenance, and so on. So, they decide to do preventive maintenance after every 5 years. There could be a different decision maker who gets a new road again, but he might decide that I will not do any preventive maintenance for the first 10 years. So, basically they will just do day-to-day maintenance for the first 10 years. However, since they have not done any preventive maintenance, their assets are likely to deteriorate at a higher rate, and after 10 years, instead of preventive maintenance, they say that I will actually do a light rehabilitation. This is another option, and so on. Now, for the next asset, say I have an old asset which is in very bad condition right now. In the year 1, I might have to do a major rehabilitation, and After that, I say once I do a major rehabilitation, I will do preventive maintenance on a regular basis. This is another option. Or one could say, I have an older asset, I will do major rehabilitation, then not do anything for a lot of years. Unless it again deteriorates a lot, it comes in a very bad state, and I might have to do a major rehabilitation again. So, I hope the concept is clear that there are n number of possibilities when it comes to scheduling. A maintenance schedule can vary based on the type of asset, based on the funds available, and based on the maintenance strategy. But any schedule which is developed will look something like this, where for each year we will know what type of maintenance should be done for this particular asset. Since there are multiple assets, each assets are deteriorating at different rates, it becomes important that we create an effective maintenance schedule. An effective maintenance schedule will help us in optimizing costs over the asset's life cycle, and this is the most important aspect. As I discussed earlier, if I do not do maintenance at the right time, then doing maintenance at a later stage will be much more costly. So, I want to optimize the cost. The idea is that delaying or deferring maintenance often results in higher costs later. For example, in case of pavements, doing maintenance at the right time can extend a pavement's life. As per a study, a US Federal Aviation Administration estimated that for every $1 they spend on preventive maintenance of their airfields can actually save them $4 to $5 in later repairs. Thus, it demonstrates the economic efficiency of doing an early intervention. Basically, what they are saying is that if an airfield is maintained during its early life, we do preventive maintenance at the right time, then the dollar which is spent on doing this preventive maintenance can actually help us in saving around $4 to $5 in the maintenance which might be required at a later stage. So, I hope the idea is clear that it is important to do effective scheduling of maintenance. Another example of this is a case of Peru, where they came up with a rural road rehabilitation and maintenance program. It was initiated in mid 1990s. They saw that if we do routine road maintenance, then the cost of maintaining the asset was actually reduced from $1,200 to $750 per kilometer. This is from a study by IMF. So, in short, effective maintenance helps in reducing cost. It might give an impression that maintenance is costly. However, the truth is doing maintenance at the right time actually saves money. Let us talk about effective scheduling with an example which we had discussed in one of the previous lectures. I had talked about this particular performance curve when we were discussing about data requirements. Now, let us see this from scheduling point of view. Say I decide to do no maintenance on this particular asset. We see that there is zero cost involved with it and there is no improvement in performance because we are not doing any maintenance. If we follow this particular curve, you see that after a given time t, the performance has come down significantly. Here you might have to do a heavy rehabilitation to ensure that the asset's performance does not go below the minimum condition which is set. So, heavy rehabilitation will come at a cost and it may increase the overall performance. So, if you follow this curve, the performance has increased but it has come at significantly higher cost. Alternatively, there could have been a thought process to do preventive maintenance at this stage. So, instead of allowing the asset to deteriorate continuously, you decide to do preventive maintenance here. Here you see that preventive maintenance also comes at a cost, but it is much lower than the cost of doing heavy rehabilitation. Also, the improvement because of preventive maintenance is also low, but doing maintenance at the right time is ensuring that the asset deteriorates at a lower rate now. Now, after a time, I might have a situation that now I might have to do a light rehabilitation. Doing a light rehabilitation will again come at a cost, but much lower than the cost of doing a heavy rehabilitation. And then again the asset will deteriorate and I might have to do a medium rehabilitation. So, I hope the concept is clear that as we move from no maintenance to heavy rehabilitation, the cost increases, the increase in performance also increases, but oftentimes it is much more productive and efficient to do regular preventive maintenance at the right time. It actually helps in extending the life of an asset. So, thus maintenance scheduling is important, especially doing routine preventive maintenance at the right time is critical. Doing maintenance is critical for preserving an asset. Everyone is aware of this fact. However, as we saw in the first lecture of this particular course, still there are several countries where maintaining and preserving an asset is important. It is important to have a good maintenance strategy to ensure that the assets can be preserved. Everyone understands this. However, as we saw in the first lecture of this particular course, it is very challenging. There are several countries in the world which have infrastructure assets in fairly poor state. This is because they have not done maintenance in the right manner. There are several challenges linked to doing maintenance. Let us talk about them one by one. Challenges in scheduling of maintenance. These challenges include fiscal constraints. Fiscal basically relates with money. There are oftentimes budget constraints. You have 100 assets which needs to be preserved, but you do not have enough money to maintain all of them. This is budget constraint. Sometimes it is also difficult to accurately estimate how much money is actually required to maintain these assets. We do not have a mechanism to get prior approval for it. Oftentimes these assets are preserved by the government, and governments require that you should take prior approval for any expenditure. So, since we cannot estimate the cost of maintenance, it takes a much longer time to get the approval to do the maintenance. This basically leads to deferred maintenance. That is, the funds are not available at the right time to do the maintenance. So, I hope the concept is clear that first of all there are budget constraints, we do not have enough money. Secondly, we find it difficult to estimate the cost of maintenance. Because of that, the approval process is much longer and it leads to deferred maintenance. We have already seen that any deferred maintenance comes at much higher costs. In addition to fiscal constraints, there are issues of political constraints. Oftentimes, political biases favor new construction. There is a perception that a new capital project often attracts political support. We often talk about this aspect that doing a new construction allows you to cut a ribbon. However, doing maintenance does not help you in gaining public's attention. So, this is another constraint because of which we do not get enough money to maintain our assets, and maintenance is not a priority for a lot of organizations. Next up, there are institutional and capacity limitations. This includes we often don't have enough people to go and monitor assets. We don't have the required skill set which is required to assess the condition. At the same time, a long-term view is missing. A lot of offices, since they have limited capacity, are just focused on firefighting. If there are any current issues, they try to maintain them. Since they have limited budget, they cannot hire a lot of resources, so they just prioritize the assets which are really in bad condition. They don't have any long-term view. This is again a problem because we have seen that doing reactive maintenance is not helpful. We need to be more proactive about it. Having said that, slowly countries, organizations, governments have started understanding the importance of asset maintenance. Asset maintenance strategies have evolved over time. Initially, we used to have more reactive maintenance. Now, we have moved towards doing scheduled maintenance, and we have also started talking about doing a more proactive dynamic scheduling. So, maintenance schedule has evolved. Earlier, it used to be reactive, where we only used to focus on corrective measures, do maintenance when needed. This used to be costly and there used to be a higher downtime associated with it. When we were doing reactive maintenance, we were not collecting any data, and any data which was available was not utilized. We were just going by the complaints. If there is a complaint, go and maintain it. Scheduled maintenance looked something like this. You have a predefined schedule. Based on your past experiences, you decide to do maintenance at a regular time. This is static planning. So, you have some static schedules where you list out, I will do a maintenance at a given time, this will be the type of maintenance, and so on. You are relying on past data. The idea is to do more preventive routine maintenance. However, doing scheduled maintenance has its own challenges, especially because it is static in nature. Here, you are saying that I will do maintenance after every 5 years, but this might not be effective. There could be a case where there was excessive deterioration of an asset in the first 2 years. Now, if you decide to do a maintenance only at the 5th year, it is not helpful. Or there could be a case where an asset was not used at all in the first 5 years. It has not deteriorated at all. Then there is no point in doing a maintenance at the 5th year. So, there is a lot of discussion going on where we are saying that we should move away from scheduled maintenance and go to a more proactive dynamic maintenance. In case of proactive dynamic maintenance, we are actually trying to leverage technology, use IoTs, sensors, digital twins, etc. to do a more demand based proactive maintenance. The idea is that a maintenance schedule should be dynamic. It should be related to how the asset is behaving, and then we should decide to do preventive routine maintenance based on the asset's condition. So, I hope this is clear that maintenance scheduling has evolved from being reactive to a more proactive approach. With that, we can conclude our lecture here. In this particular lecture, we talked about different aspects of what is maintenance, the role of maintenance. We also saw how maintenance is linked with the performance. I talked about different types of maintenance, what are the alternatives. Then we discussed the aspect of maintenance schedule. We talked about how does a schedule look like. Then I discussed challenges in maintenance scheduling. The next step is decision making. Once we have talked about data collection, we have all the relevant data, we know a mechanism to model the performance. we understand all the alternatives, what options I have, then we have to finally take the decision. We need to decide what will be our course of action. Decision making is critical, at the same time it is very difficult. When we take a decision, we have to account for our policies, our goals, as well as the budget available. So, before we start discussing different decision making techniques, first we need to discuss about budget. What is maintenance budget and how do we go about deciding the budget required for doing maintenance? I will talk about it in the next lecture. Now, here are some of the references which you can use to dive deeper into these concepts. With that, I conclude this discussion here. Thank you. Thanks for listening.